Hey friends, today we're going to look into this free response question from 2019 AP Calculus BC free response section. So, gives us a curve that was named S. It is a region bounded by the graph of the polar curve r of theta. So we're trying to find the area of the shaded area of S. So we know that the equation for trying to solve for the area in the polar curve is 1/2 the integral from where this beginning and to where its end is going to. So for this question, it's going from 0 to square root of pi. So it's 1/2 the integral from 0 to square root of pi of r squared. In this case, it will be r of theta all squared d theta. So this is the equation for the area, and what we get is just plug into the calculator. So it's area equals 3.534. Okay, and then moving on to section B. For section B, we're trying to calculate the average distance from the origin to the point on the curve given that interval. So what we need to figure out is that the distance from the origin to the point on the polar curve is r of theta, the function itself. So if we're trying to find the total distance from the origin to the point on the curve, it will be the integral from 0 to square root of pi of r theta d theta. This will be the total distance from the origin to the point given this interval. And if we're doing the average distance, we're going to do 1 over square root of pi minus 0. So this will be the average distance. And then if we just plug it into the calculator, we will get 1.580. So the hardest part for this question is to figure out what the distance from the origin to a point on the curve is. And then don't forget to divide the integral expression by square root of pi minus 0 to get the average distance. Okay, for section C. For section C, it says there's a line through the origin with the positive slope m that divides the region S into two regions with equal areas. So we can figure out that if the line is going through the origin with the positive slope of m, we can write this equation as y equals mx. Because it's passing through the origin, there shouldn't be plus anything behind. So it's just y equals mx. So we can derive an expression for m, which is m equals y over x. So we also know that in the polar equations, tangent of theta equals the same thing. And then so we know that tangent of theta here will equal to m. Okay, so we're gonna save this conclusion. M equals tangent inverse of theta. And we're trying to see that this line divides the region S into two regions with equal areas. So first, what we can do is that the area of the region that was divided by the line will be from the origin to the line where it so imagine this will be the line y equals mx. So we're trying to say that the area from 0 to whatever this theta is equals the area from theta to square root of pi. So we know that the area in the polar curves can be represented as 1/2 of the integral of r squared d theta. So we can say that the area from 0 to theta is 1/2 the integral from 0 to theta of r of theta squared d theta equals half of the total area, so which is 1/2 times 1/2 of 0 to square root of pi r of theta all squared d theta. And then if we divide both sides by 1/2, we will get just, and then we can also, we know that m equals tangent inverse of theta, so we can tell that theta equals, wait, sorry, we got m equals tangent of theta, so we know theta equals tangent inverse of m. So we can plug in tangent inverse of m for theta. So the first way of expressing it will be this, or we can say that the area from 0 to tangent inverse of m of r of theta all squared d theta equals the area from tangent inverse of m to square root of pi of r of theta squared d theta is equal. Well, because the area for both are 1/2 the integral r squared d theta. I'm just going to ignore the 1/2 on both sides. So this will be the first way. The second way of expressing the solution that gives the value of m. Okay, let's move on to the last section, which is probably the part where most people don't get for this question. So for part D, it says for k is greater than 0, let a of k be the area of the portion of region S that is also inside the circle r equals k times cosine of theta. Find the limit when k goes to infinity of a of k. So first, we need to figure out where the two regions intersect. So we need to find the theta value. So let's say this is the theta value that r equals k of cosine of theta with intersects with r of theta. So it will come out to be an equation that is r equals r of theta, which will be k times cosine of theta equals 3 times the square root of theta times sine of theta squared. So what we know is that cosine of theta equals 3 times square root of theta sine of theta squared all over k. And then theta is just cosine inverse of the whole thing on the right side of the equation. My apologies. Okay. So after we come out with this expression for theta, and we know that k is going to infinity, we know that the limit of theta as k goes to infinity, we know that k goes to infinity for this k goes to infinity for this expression. So k goes to infinity. The denominator will be super large. And we know that this whole thing will go to 0 as k goes to infinity. So the limit of theta as k goes to infinity will equal to cosine inverse of 0, which is just simply pi half. Why is this helpful? Because we get the value that theta equals pi half as k goes to infinity. So we know that the actual place that r and r of theta intersect is right here. It's on the y-axis. So if we're trying to find the a of k as k goes to infinity, we can just simply tell that it is the area of S that is on the right side of the y-axis, so which is from 0 to pi half. So we can just simply do the limit of k goes to infinity of a of k equals 1/2 of the integral from 0 to pi half of r of theta all squared d theta. And if we calculate that, we'll get a number that is equal to 3.324. Also, when you think about this, the circle r equals k times cosine theta. It's going to be a circle that looks like this as k gets bigger. So it starts from the origin of the xy plane, and then it's a circle expanding to the right side, so to the positive x-axis. So we know that as k gets bigger, eventually when k approaches infinity, this circle is gonna include the whole area that is to the right side of the y-axis, which is the positive section for the x-axis. So the whole area, the whole area that is on the right side of the y-axis will be the area for the circle R. And then we can simply just tell that the part that is intersected is the region of S that is on the right side of y-axis. If it's easier to think of that way, but you need a mathematical explanation for why the upper limit for this integral is pi half. Okay, I hope this will help you understand this question better. Thank you.